And that happens to be, people use this word incorrectly all the time. Weight. Weight, by definition, is mass times the acceleration due to gravity. And we say due to gravity because gravity can change depending on where you are in the universe. And so, normally we're going to say it's 9.8 meters per second squared because we're normally on the Earth. If we're on the Moon, acceleration of gravity is going to be less because there's less mass. If you're on Jupiter, it's going to be greater because there's more mass. And less than Jupiter, but more than Earth. And so on. So, weight is not what your scale tells you. When we said that Mr. Shoes had a mass of 85 kilograms, that wasn't his weight measure. What is weight measured in? If you'll notice that if it's mass times acceleration, that looks an awfully lot like Newton's formula. So weight is measured in what unit? In newtons, because weight is a force. Say it with me, people. Weight is a force. And force is measured in newtons. Okay. Let's go with me. Ready? Yeah. Weight is a force. Force is measured in newtons. So, what's the unit for weight? It's newton. Okay? Now, this is the force on our mass. Okay? It's this force acting on our mass. And that is due to the acceleration of gravity. Okay with that? Now, what does a scale do?
Doesn't it measure, like, it measures your weight, but doesn't it measure, like, the force of gravity pushing on you?
It measures the weight, but then converts it to mass, which is the unit of pounds or kilograms, etc., etc. Right? So when I say go mass an object on those balances over there, I'm being very specific. I don't want the weight. I want the actual mass reading. And the scale takes, it's been configured and calibrated for Earth's gravity. Right? So it has a certain resistance or a certain balancing to it that it says, okay, we're going to take this 9.8, we're going to do a conversion, we're going to go back to you in mass. Right? So it takes the weight, converts it to mass, and reports to you in mass. So when I ask you for mass, you'll give me kilograms. When I ask you for a weight, you'll give me
Newtons.
newtons. Not pounds, Mr. Mung. So here's the deal. If weight is due to mass times acceleration due to gravity, and acceleration due to gravity is roughly 9.8 or times 10, then you could take your kilogram and just multiply by 10 and essentially have your weight. So if I weigh if I have a mass of 85 kilograms, then my weight is roughly going to be around 850 Newton. So weight measurements always make people look fat, even though it's not. Okay? So later on, we're going to do acceleration on your own bodies, and when you determine weight, you're going to have to determine it in what unit? Newton, and it's going to seem higher than you think it should be because you're used to using pounds. All right? Not newtons. And newtons takes into consider gravity. And this is very important when we talk about terminal velocity. Did we already say what terminal velocity was? Okay. So terminal velocity is what happens when the acceleration due to gravity, or the force due to gravity, is going to equal the force due to air resistance, right? Yes. When they're equal. Well, this force due to gravity, what's that called? Just covered it. Weight. So this is the weight of the object. So when the air resistant force equals the weight of the object, that's when you reach terminal velocity. So you go to something like this book, right? Did this book reach terminal velocity?
No.
No, it kept accelerating the whole time. What about this piece of paper?
It reached terminal velocity.
It did. It stopped accelerating.
It did.
Now, did it stop falling?
No.
No. It just got up to speed, its terminal velocity, and did not accelerate anymore. And you saw it float nicely. Right? Because its weight was met by air resistance far more quickly than its weight was. So, you drop an elephant and a feather at the same time, which one's going to hit the ground at the same time?
Elephants.
Elephant's going to hit first every single time because it's not going to reach terminal velocity until a lot later than the feather. So it's going to fall faster. However, let's do the same experiment on the moon and give the feather and the elephant, just for control purposes, both some air to breathe, a pressure suit, well, for control. And we drop them both on the moon. There's no atmosphere. Which one's going to hit the ground first?
Both at the same time.
At the same time. Why, Mr. Perkle?
Because they both reach terminal velocity at the same speed.
Oh, I know.
Because, yes?
Because they have the same mass on the moon.
No, because there's no terminal velocity on the moon. They're going to keep accelerating and accelerating and accelerating because there's no air resistance. There's nothing to stop them. Right? And so, oh dear. And so Newton's first law of motion states that they're going to keep on going because there's nothing to slow them down, inertia, right? The only thing opposing them is nothing. The only thing going for them is gravity. So they're going to keep accelerating, 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 going faster, faster, faster. Now, granted, on the moon, the acceleration of gravity is less than on the Earth, so they'll accelerate more slowly, but they'll up to a higher velocity than they would on the Earth. Question?
Isn't paper still accelerating? Isn't it accelerating if you drop it straight down like that?
No.
Floating down?
Eventually, let's say it just keeps falling straight down like this, right?
Right.
So it's going to accelerate until it reaches its terminal velocity.
Yeah.
Then it stops accelerating. But remember, it's terminal velocity. It's still moving. It still has a speed.
Okay, but does it?
But it's not going to go any faster.
Okay, but what if you drop it straight
But then
down?
if you do like this and it switches over, it's going to
Go faster.
accelerate again, come to its new terminal velocity. Because it's experiencing less air resistance. Less surface area, less air resistance. So if you crumple it up, it'll be much more uniform.
Yeah, okay.
You weigh 194 pounds.
Oh, is that 85 kilos?
He does not weigh that
85,
much.
so it's 800.
I have a mass of that.
His mass
Mhm.
is that.
Okay, any questions on this stuff?
Nice job, baby.
So, come next Tuesday, we'll have a quiz on this stuff. Come Monday, we'll probably go over your tests. And mostly be a research day. Because we shouldn't have that. You want some homework?
No.
No.
Yes.
He's just kidding. It's not.